Good morning, students. Today, in the front-end design tool, VB.NET, we will discuss JIT, that is the just-in-time compiler, assembly, and garbage collection. So, first of all, we will start from JIT. Okay, JIT, assemblies and garbage collection. So, now we will start from JIT, that is the just-in-time compiler. Just-in-time compiler, which compiles MSIL, that is the Microsoft Intermediate Language, into native code that is specific to the operating system and machine architecture being targeted. Okay, so the just-in-time compiler actually converts the MSIL into the native code that is specific to the OS. Whatever the OS you are using in that will be compatible to that, and it will be compatible to the architecture being targeted. So only at this point can the OS execute the application. The just-in-time part of the name reflects the fact that Microsoft Intermediate Language, that is MSIL code, is only compiled as and when it is needed. So first of all, you have written a code in the programming language, it is converted into that compiler of that particular programming language, and then it is converted into the MSIL, and this MSIL code is only compiled as and when it is needed. Means to say when it is needed, then only it can be run with the help of the just-in-time compiler. In the past, what happens, it was often necessary to compile your code into several applications, each of which targeted a specific operating system and CPU architecture. Mean to say, the target of things will be, specific. Suppose operating system is different, CPU architecture is different. So you will have to write the code according to that, and you will have to compile according to that. So it was earlier, it was the practice, but now often this was a form of optimization. So you will have to make some sort of optimization, you can say that you will have to write a program in such a way that it will be specific to the certain CPU architecture and certain operating system, so that the performance of this will be good. But this is now unnecessary because JIT compilers, as their name suggests, use MSIL code which is independent of the machine. Actually, MSIL code is independent of the machine because you are having one programming language, and that programming language is having one compatible compiler, and that compiler actually convert the code into MSIL, Microsoft Intermediate Language, which is independent of the machine. So this MSIL code, which is independent of the machine and operating system and CPU, MSIL code is independent of the machine, operating system, and CPU. It is independent from these three things. So this optimization sort of things is not necessary in this case, because it is converted into the middle level things, you can say MSIL. Now, however, this in the .NET, the several JIT compiler exist, each targeting a different architecture, and the appropriate one will be used to create the native code required. The beauty of all this is that it requires a lot less work on your part. In fact, you can forget about system dependent details and concentrate on the more interesting functionality of your code. So the beauty of this, that you will have to focus on or your code, or programmer can concentrate on writing their code. The programmer don't worry about the system, whatever the memory is needed, how much memory is needed, it is required, allocation of memory, access type of memory, allocation, deallocation is required. All sort of thing is not required in this. So the programmer must, just concentrate on writing their code and nothing else. JIT are of three types. Just-in-time compilers are of three types. One is called the pre-JIT, economic JIT, and normal JIT. So pre-JIT, it converts all the code in executable code and it is slow. Pre-JIT actually it converts all the code in executable code. Whatever the code is, right, just convert all the code into executable code. That is why it is also slow. Economical JIT, as its name suggests, it is also economical. It will convert the called executable code only. Whatever the code is called executable code, it converts only that code only. But it will convert code every time when a code is called again. So every time, whenever the code is called once, twice, thrice, every time it is called, this code, it convert the code every time when it is called. So you can say this, unnecessary, this thing is increasing. The third one is normal JIT. It will only convert the cold code and will store in cache. Since it is stored in cache, so that it will not require converting code again. Again and again, the code is not required since the code is stored in cache. So this is normal JIT, and normal JIT is fast. Now we will discuss a very important topic that is called assemblies. Assemblies, when you compile an application, the MSIL code created is stored in an assembly. When suppose you are writing a program in C++, you are using the C++ compiler. With the help of the C++ compiler, that code is converted into the MSIL. So the code, this MSIL which is created, actually is stored in an assembly. Assemblies include both executable application files that you can run directly from Windows without the need for any other programs. These have a .exe file extension. As you know that .exe file extension, you can just you can make the .exe file extension, or you are having a files which is having .exe extension that can be directly executed. You need not to require everything or some setup sort of thing for that. You just execute that .exe files. And they are also having the libraries which is having a .dll extension. .dll means dynamic link libraries. So this is for use by other applications. .exe files can be executed directly. .dll files actually used by other applications. Suppose there are two applications. So one applications can use another this DLL files. Okay. So DLL files will be used by another application. In addition to containing MSIL, assemblies also include meta information. So first thing, assemblies contain MSIL code. That is the first part. Second point, assemblies also include meta information. Meta information means to say, as we know, what is metadata? The data about data is called metadata, or the meta information, that is information about the information contained in the assembly, is called meta information, also known as metadata. So metadata actually used by the MSIL, such as sound files and pictures. So the the information about a particular data is also stored in by this. Now the meta information enables assemblies to be fully self-descriptive. Meta information provides the assembly that it is fully self-descriptive. It is need not to to define it further. So you need no other information to use an assembly, meaning you avoid situations such as failing to add required data to the system registry and so on, which was often a problem when developing with other platforms. So it means when you are developing some things, and sometimes it may be required by the programmer that they just forget for the system registry or some additional things. These all things will be done with the help of these assemblies. So it's a very easy task. This means that deploying application is often as simple as copying the files into a directory on a remote computer. Mean to say, when you will develop an application and when you are going to deploying the application is very easy. It is as simple as copying the files into a directory on a remote computer, because no additional information is required on the target system. With the help of the assemblies, because assemblies is also having meta information, all the information they are having, so you need not to having some additional information. You can just run an executable file from this directory, and assuming the .NET CLR is installed, you are good to go. Of course, you wouldn't necessarily want to include everything required to run an application in one place. You might write some code that perform tasks required by multiple applications. In situations like that, it is often useful to place the reusable code in a place. Global assembly cache. Global assembly cache, where you will write reusable code in a place accessible to all applications. So in a global assembly cache, we are putting the code which can be accessible to all the applications. Now we will discuss garbage collection. .NET garbage collector manages the allocation and releases of memory for your application. Each time you create a new object, the common language runtime allocates memory for that object from the managed heap. As long as address space is available in the managed heap, the runtime continues to allocate space for new objects. However, memory is not infinite. Eventually, the garbage collector must perform a collection in order to free some memory. So the garbage collector's optimized engine determines the best time to perform a collection based upon the allocation being made. When the garbage collector performs a collection, it checks for objects in the managed heap that are no longer being used by the application and performs the unnecessary operations to reclaim their memory. So do you understand with this garbage collection? Actually, garbage collection, what it does, actually it sees whatever the memory is no needed, it actually release that memory from the system. So when the garbage collector perform a collection, it checks for objects in the managed heap that are no longer being used by the application and perform the necessary operations to reclaim their memory. In the CLR, or the common language runtime, the garbage collector serves as an automatic memory manager. It works as a automatic memory manager. So there are some benefits of the garbage collection. Let's see that. It provides the following benefit. Number one, it enables you to develop your application without having to free memory. Memory deallocations, you need not to worry about the how you will deallocate or free the memory. Allocates objects on the managed heap efficiently. Reclaims objects that are no longer being used. Clears their memory and keeps the memory available for future allocation. Managed objects automatically get clean content to start with, so their constructor do not have to initialize every data field. It provides memory safety by making sure that an object cannot use the content of another object. So these are some of the benefits of the garbage collections. In the next class, we will discuss exception handling and code access security. Thank you. and we will meet in the next class.